So if you've seen the schedule or if you've heard about CI/CD tools and the title for this, it's changed slightly. I swear it's not about CI/CD tools, it's about attacking CI/CD stuff. But there's a quick little primer to this because it's not necessarily the most accessible topic, and there's a couple of acronyms in there. If I ever say anything and I just use an acronym and you don't know what it is, just shout out, just yell at me. I've tried to get them all out of there. But there are a couple of topics that we need to know to make this cool, so we're going to go through that as well. Just before we get too far into it, hands up, just quick show of hands, who knows what CI/CD means, or DevOps, or who has anybody here used GitHub before? Yeah, okay, there we go. Okay, we're in that kind of space. But I come at this from an offensive sort of security standpoint. I'm in the red team at Skylight Cyber, so I'm trying to attack these things. I'm not a developer. I don't know how to develop code. I write quick and dirty scripts for things. That's as far as I go with code. So I'm coming at this from some practical examples of stuff that we see in the wild on jobs when we're attacking companies. And it's a kind of recurring problem, quite a modern problem that's probably going to come up for 99% of the people in this room. As you go into the workforce, you're going to encounter these things. And they keep getting it wrong, so maybe this will help. So I'm going to quickly run through what these things are, how to attack them with some practical examples. There is a cheat sheet at the end that's quite a technical specific cheat sheet if you want to take some of this away and play with it yourself and have a look at it. So don't feel like you need to take notes or pay too much attention to the specifics. It's more about the concepts, and we've got some pretty graphs to take you through. But as a quick primer, before we get into attacking these things, what are these things? What is DevOps? What is CI/CD? What is a runner? DevOps is kind of depends who you ask as to what it means. Some people would say it's a philosophy or a culture. It's developers and traditional IT, and then traditional IT is becoming cloud-based IT now as well. And then sometimes you get security tacked on, in which case it becomes DevSecOps. But really, it's just a smashing together of what was traditionally developer land, where people were writing code, they were writing software, and IT people who were building laptops and maintaining servers and things like that, maintaining a network. They were very different teams, and they had very different skill sets. Now, more and more, they're being merged together. It's more efficient, things run faster, and a lot of it is predicated on being able to automate a lot of things. So traditionally, if you were writing a piece of software for a big organization and you needed to push it to production, the concept of production being it's going to the public, it's going live, whether it's a website, a mobile app, a piece of software that you install on your laptop, it needs to be tested and go through various tests to make sure that it works and that it's safe. And there was a long lead time to do a lot of this. You would push it, it needs to get reviewed, it needs to go through a testing phase, and then you can't change it while it's being tested, and then it needs to be rolled out and pushed in a consistent way to everybody. That takes time, and developers hate that. So developers keep finding ways to not do that process, and this is kind of a helpful way to keep everybody in line, but also make things quicker. What this means for IT, specifically not developer software land, is the same tools and principles apply to them as well. They want to run out servers really, really quick. They also hate doing their job. They want to be as lazy as possible. Developers and IT people share this common theme of being very lazy at their jobs. So they want to automate it as much as possible. If you've built a server once, you never want to have to build it again. You build the way to build the thing and then push it out. You want 100 of them, run it 100 times. That sort of automation logic. CI/CD is just a fancy acronym for continuous integration, continuous development. It's the concept of, if you're familiar with the concept of agile development, it's taking that one step further in terms of it's that continuous loop of, I'm a developer, I can change code and do anything I want at any time, and I'm not blocked by somebody needing to review or the environment not being ready, things like that. It's having a continuous environment for that. If you don't care to remember these terms, just think automation. Think developers and IT people are very lazy. We like to automate things. And this is where runners, or sometimes they're referred to as builders, I'm going to call them runners for this. That's where they come in. So runners are typically just a VM, a virtual machine, a piece of compute. It's usually in a cloud somewhere. It's in AWS, it's in Google, it's wherever. That is set up very specifically. Humans don't touch it. It doesn't have a human guiding hand. It's given a script, it's given a piece of code, and it will run it, and it will run at the same time every time. And you might have a fleet of these things all doing very discrete, little, tiny scripted problems, and then together they form a sort of pipeline. builds a VM, it pushes files to it, it tests that they're all loaded correctly, it tests it has access to the internet, spins up a web server, pushes out a DNS record. Now we have a website that's been pushed out to the public. Humans don't want to do that. Humans keep screwing that up, so we let the machines do it, basically. So this talk is going to focus on that sort of pipeline and how people use that and how we like to attack these things because people keep messing it up. GitHub, GitLab, Cloud Build are some examples. There are dozens of these things. Cloud Build calls them builders, GitHub calls them runners, so we're going to call them runners today. The focus is on GitHub, but there's also a GitLab example in here. All right, so just as a quick primer for everybody, I'm going to show you what it is. And this is a live demo, so hopefully it works. Everybody is probably familiar with what this looks like. This is GitHub. People put code in here. We have repositories, and we store code here. This is the cloud version. There is an on-prem version, which is also part of this. But the concept here is I'm a developer. I get given access to my company's super secret app source code or whatever. I need to be able to push code into things. And also as a developer, I shouldn't be beholden to somebody making a server for me in order to test something. I want to test it myself at my own time. So GitHub has this concept of GitHub workflows. If you go in here, I'll just show you what one looks like. This is YAML definitions, but basically this is a very simplified one that, you can see my mouse, yep, that says whenever code is pushed, or this just means manually trigger this workflow, it will run a job called some code that wants to run on the latest version of Ubuntu that this thing has to offer. So as it gets updated, my test environment will automatically get updated. Yes, sorry.
Can you zoom in a little bit?
Yep. Better? It's running on Ubuntu because that's what I've asked for, and it's going to check out some code of mine, and then it's going to run a script, and this is where it all goes horribly wrong. A lot of these runners can be programmed to run anything. They are just a piece of compute, and I can give them a script. And if they're not secured, they can run pretty much anything. It's like being given access to somebody else's computer. In this case, I can work out the host name, I can work out the uptime, the environment variables, I can make it curl out to the internet, I can make it start attacking things, I can make it do whatever. This is a very simplified example, but just so you can see what it looks like, when you would change code, it would automatically, GitHub automatically does this for you. You can sign up right now and do this for free, it doesn't cost anything. And this will run on Microsoft's Azure VMs. They spin up a VM for you, it'll push your code to it, and it'll run it. It doesn't cost you anything. So here it's going, it's creating, hopefully you can all see that, it's creating a Ubuntu environment, it's Ubuntu 20, that's what I asked for. It checks out some of my code, and then it will run my script. And here are all the environment variables inside of their VM. I've asked for its host name, its uptime, its environment variables. This is the host name in some, I'm guessing the AZs for Azure, that I've been given. And it runs for a couple of seconds, and then they tear it down, and then it all goes away. And I run another script, and it stands up a whole new VM, and it starts all over again, which seems wildly inefficient, but what do I know? But what's interesting about this is I can ask it to pull out all sorts of things. If this was a shared environment, somebody else was using the same runner, then we have a conflict of I can potentially look at what they're doing, and that's where we're going with this. So just know this exists. You can totally use this, and as people loosely in the IT space, this is more and more relevant to people, whether you're a developer, whether you're an IT person, whether you're going into sort of cloud build, not necessarily security, you're probably going to encounter some of this stuff. And knowing how it works is super helpful for being lazy, but also super helpful for attacking these things. Righty. So what I might do too, actually. So this is an example of, say this is a mobile app, and I'm a developer, and I've started the first day on my job, so I need access to this source code. But what I should not be able to do is push changes to the mobile app. I shouldn't be able to willy-nilly change code that goes into production, right? And so there are various restrictions that would be placed on me. Typically, there's this concept of a main or a master branch, which is where the production code lives. It's the secret source. It's the source of truth. If it changes, something bad could happen. I could change a website, for example. So just as an example, if I tried to change the README for this, I'm not allowed to. I can't commit to main. I can create a new branch, but this is a protected branch, so I'm not allowed to. I'm not trusted. I'm not a lead developer. It's not my job to be able to change these things. I can submit proposals to change code, but then what happens is I go, yeah, okay, that seems like a good idea. Let's change this code. And it goes, no, I need a review. I got to get my boss to review this. He's got to approve it. I got to get a peer review. I can't just push things into production. And this is what we're trying to bypass. If I'm a rogue developer or an intern on day one and I want to really change some stuff, I need to be able to pass this. This is fired off a million emails. Somebody's like, oh, Alex is trying to change things. I don't want them to know that I'm trying to change things. So this is kind of the sort of workflow and the protections that we're trying to bypass. As an example, where we're going with this is, so if I wanted to run a workflow that lives on GitHub's Azure cloud stuff, that's very segregated. That's GitHub's problem to protect. What a lot of companies do though is, for whatever reason, you might need access to an internal resource as a developer. So you create your own runner, hook it up to GitHub, and you host it on-prem. You host it in your office somewhere. You host it in your private cloud that has access to maybe your internal databases, your internal repositories for things. GitHub can't access these things, so there needs to be some way to merge those two together. And it's this concept of a self-hosted runner. Running here, these are GitHub-hosted runners. These are SaaS runners. And if I wanted to change these, if I take a different definition, what I can do, and this is a big problem that we see everywhere, so do look out for this, is I can't change production code, but what I can do is I can create a feature branch. Because that's not changing production code, so there's no restriction against doing that. So now I have my own test version. This is never going to go to production, but what it can do is it can run code, and I can add files to this. So we'll do a run on self-hosted. This is a script I prepared earlier. And what this does is it's basically the same thing, but you'll see it's now self-hosted. So the organization has created these organization-wide runners for developers to run test code on. That seems safe enough, that seems reasonable. But what I'm asking it to do is give me some AWS secrets. Now, I probably shouldn't be able to do that as a developer. These secrets are designed for runners. They're designed for machine accounts to be running on. A human was never supposed to interact with these things. These runners are supposed to be left alone. But there's nothing stopping me from maliciously making it spit them out or do anything I wanted. So I thought it would be interesting just to show you what this looks like. See, now I can commit directly to this custom feature branch that I have. If I save that, because it's in this magic directory, GitHub automatically knows to run it. So here goes my self-hosted one. It's picked it up. Hopefully this works. Starting a job. And the difference here is it's running on this one I prepared earlier. This is my runner that's running in a cloud VM somewhere. So my code is now running on somebody else's VM. It sets up my job, and it runs the script that I gave it. It'll do whatever I want it to do. And this is a good example of, if you look at the script that I fed it, I asked it to please echo out these secrets, these AWS S3 ID and key secrets. These are for my S3 bucket, which would be a storage bucket in AWS. GitHub won't let you do that. It knows it's a secret. I'm not supposed to have access to that, so it stars it out. But if you do something stupid, like stick a space in between part of it, it will spit it out. This is the key right there. So it's not trying to protect you from doing something malicious. It's trying to protect you from making stupid mistakes. And if you really want to do something stupid, it'll let you. So just bear this in mind as a simplified example of these things have secrets, these things can run pretty much anything, and this is an example of one that's not running in Azure. This is running hypothetically inside my corporate network. It has access to databases, it has a whole network behind it. I can start SSHing and accessing all sorts of different things. So, what is the problem with this? That we keep seeing. So lots of organizations start out very small, they build a piece of software, it's wildly successful, the company grows, now there are 100 people, and they didn't really bake in a lot of security to this. Instead, the developers and the IT people made these pipelines and these runners to get stuff done, to be lazy, to automate things, and then they left it alone. There's secrets lying around, they're sitting in environments that they shouldn't be, and they have access to things that they shouldn't be. So we're going to look at this concept of test versus production. Traditionally, this was sort of test code moves and becomes production code when it gets reviewed. But now in repository CI/CD land, all code could be production code. It depends where it's running. Does a runner need to be a production runner or a test runner? Does it matter? Can I run the same type of code on two different runners or the same runner? Is it safe? A human shouldn't be able to meddle with it, but maybe they can. So this, we've got two worked examples for you. These are based on real companies that I tested, that we did some serious damage for in terms of being able to get access to resources that we shouldn't. So I want you to meet Developer Dave. Developer Dave, he's new to the job. He works at we'll call it a healthcare provider software development company. If you've had a vaccination recently, you've almost definitely used these systems. So Developer Dave is working on a system that affects most of the Australian population. He works at this company. They have a lot of patient records, they have a lot of medical records, that sort of thing. That's the thing that they're trying to protect. Now, Dave's not a rogue developer, but if he was, he should be able to access his email and some documents. He should be able to change test code. That's within the spec of his job. He shouldn't be able to change production code. He's not a lead developer. He needs to get approvals for that, like we just saw. He shouldn't be able to access the product environment. He shouldn't be able to access their other products. He works on a very specific product. He shouldn't be able to access customer data. Nobody should. He shouldn't be able to turn everything off. And he shouldn't be mining crypto. But these are all things that we'll see that he could have done. For context, Dave, he works on the OS X version of this piece of software. It's a COTS product. It gets pushed out, so for Mac users, he does the specific testing to make sure that their product works on Mac laptops. That's his entire job. He doesn't need to be able to do anything else. And just as a quick day in the life of what Dave does, Dave works from home. He loves working from home. He never goes into the office. He could, but he almost never does. He uses a thing called GitLab, very similar to GitHub, but it's self-hosted instead. He can access test branches, he can't access master branches, he can't access production code. And he can run these workflows, as I just showed you, he has a Mac Mini that he set up. He put it on his desk before he left, and it just sits there. It's got a sticky note on it that says, do not turn off. It sits there, it runs Mac-specific code because it's quite hard to virtualize that, so he needs a physical device. It sits on his desk, and it occasionally pushes stuff into storage when it finishes and outputs successfully. It passes all the test cases, store it. He also accesses the network over a VPN, and so he can get back to his test outputs if he ever needs them. And he can get access to Office 365, Azure resources, his email, SharePoint documents, things like that. This is all he really does. We as attackers have come along, and we've compromised Dave's account. Dave, he's a great developer, but he sets terrible passwords. There's been a password leak somewhere else, and it turns out he uses the same password. And this is a simplified version of what we did, but more or less this is what happened. With Dave's password, we can't access the corporate network because the VPN has MFA. It has 2FA, multi-factor authentication. If I try to log in, it dings on his phone and says, do you approve? And he goes, no, he's savvy. He's not going to hit approve. So we can't get onto the internal network. We also can't get to his email or any important documents because also Azure, it's got MFA turned on it. So with just his password, we can't really access these things that we would like to access. And this is how it should be. Unfortunately, all the developers, when they started working from home, started complaining that every day they had to log in and they had to MFA every time they were trying to submit code. And the process was too laborious, and they kept complaining to IT. So what IT did was they turned MFA off for GitLab access for non-lead developers. The thinking being, if they're only touching test code, how bad could it really be? They can't push anything to production, they can't approve anything. Those people, they have to do the annoying MFA step. Dave's not one of these people. So now as an attacker, we can access the test branches that he can access as well, which means we can similarly push a job to a runner that exists in their internal network. Remember, this is a physical Mac Mini sitting on his desk. The issue with this is that Mac Mini can then reach out to the internet because it needs to update itself, access libraries and things like that. So we created a tunnel that reverses back out of their network, and now we have a foothold on their network. This is all from just regular access that Dave should have. From here, we can start staging and attacking other things on their internal network, people who are in the office, databases that might exist internally, things like that, looking at files on share drives, things like that. But we can also access the Azure environment and his email and SharePoint because this organization had a trust set up that said, if you're coming from the office, you don't need to MFA, you don't need two-factor authentication because you're already in the office. We trust that where you're coming from makes sense. So in this way, we've skipped over that step to get into the Azure environment so we can access his emails. We could do a lot of damage as Dave at this point. But rolling it back, there is this master branch, and really that's where we want to get to for this particular product. Dave can't access it, but lead dev Lenny, he can. He comes in here sometimes, and he updates things. And all we have to do is wait on this runner and sit there watching for jobs to come through. As lead dev Lenny comes along, he'll push production secrets into this runner because it's a single Mac Mini that sits on the desk, and they have to use the same one for everything. So production passwords will come through here, production code will come through here. And if we sit there, you'll see the files get checked in, and you can start changing them before it gets pushed to storage, before it gets built, before the product is completed. So you can put a backdoor into a piece of software. You can also pick up the passwords and the secrets that they use to push these things to storage. Maybe they push them straight to a website, things like that. So we've got access to that production build pipeline purely because they're using the same runner for both environments. But what I said at the start of this was that there's also this concept of like a shared runner. This runner is very specific. It's a Mac. It's for these specific jobs. They also had about 20 other shared runners throughout the organizations, and these were all hosted in AWS. These were for the other products that they use that Dave doesn't touch on a day-to-day basis, but they're shared. If you have access to GitLab, you're allowed to run on these runners. With his regular, everyday, non-lead developer level of access, he can push jobs through these runners to other products, their SaaS product, their web-facing product that was live in their live environment. They have a test and a production. They're using the same runners to basically administer both, to keep both happy. That has access to patient records, medical records, that sort of thing, so that was quite a severe impact. And the IT people were also using it. Remember, it's not just developers. They're using this as kind of an infrastructure as code. They push it a definition for what their cloud environment should look like, and it creates VMs, it accesses storage. Basically, it racks up a bill, is what you can do with this. So there's passwords in there that say, yeah, if you feed AWS this password, I'll make a VM, I'll make compute, you can put 1 million GPUs in it, you can make it as expensive as you would like, on somebody else's dime, on this company's dime. So you could start mining crypto and doing anything you wanted there. Any questions about that? I know that's a very quickly glossed through example of how this sort of works. But I guess the main takeaway is this all comes about because these runners are shared between production and non-production, right? Dave shouldn't have access to production secrets, and he doesn't, but he has access to a piece of infrastructure that does. And we see this screwing up a lot of the time. Ultimately, we could access patient records by impersonating him. We could turn off their SaaS product. So their COTS product, their software to install on a laptop, not the end of the world, but anything that's running in a cloud environment that you can turn off, pretty bad, pretty big impact. And we could attack the rest of their network, which we then did. How am I doing for time? I'll keep going. We got time. The other example that I wanted to run you through is a bit simpler. This is more on the IT side. So this is for the IT people, less so for the developers. But it's interesting to see how they interact. So we've got an IT owner, Izzy, and she's very lazy. She's the extreme version of laziness, and that makes her excellent at her job. She's not a developer. She doesn't develop code, and she doesn't really understand what the things she's building for the developers do. All she knows is she keeps the lights on, everybody's happy, nobody's complaining, stuff keeps working. So what she did was she manually created, this was a GitHub and a GCP, so a Google Cloud hybrid environment. She manually built a server and built a script to automate the creation of the automation runners. So she automated the automation, which is very clever. This VM, this master VM, basically, its job is to create things as they get destroyed. If it needs to scale out, it will scale out. If things break, it tears them down and builds a new happy, healthy one. It's just keeping an eye on things and monitoring them. Some of these runners that it produced were test, some of them were for prod. Izzy doesn't care. Everybody gets access to the resources that they need. If you're unfamiliar with it, Google Cloud and really all cloud environments have a concept of it like a KMS, which is a key management solution. Basically, it's the thing, if you pass an encrypted blob to it, it will decrypt it for you. In this case, they were using it for passwords. So developers shouldn't have access to passwords. They can now get access to an encrypted version of it that's kind of useless. And this is what they typically did. They stored them in GitHub, which is not a terrible idea. They have access to the encrypted blobs, and provided they can give it to an environment that can reach the decryptor, it will decrypt it for them and put it onto the runner. No human involved. The human stops at the GitHub checkpoint. So depending on which pipeline, which route it goes down, which runner it ends up, it'll get a test encrypted password or a production encrypted password. But either way, even if I gave them to a random person on the street, you can't do any damage with them. They're not useful in their encrypted state. What ended up happening because of the way that they built this, though, was the concept of a day one rogue intern is what we were sort of posing as. What could you do as a random developer that doesn't have a lot of access is you can commit a test run, similar to what developer Dave could do. They can go to the test environment, but because I have access to the encrypted version of production, super important secrets, I could run them through the test environment and from the test environment, push production encrypted blobs to the KMS and ask it to decrypt it. Basically says, decrypt production secrets for me. Who are you? It's okay, Big Boss made me because Izzy made this thing. Izzy made this test environment. And so they had equal weight in terms of how they were authenticating, how they were identifying. They got labeled as, these ones are test, these ones are prod, but under the hood, they're all running the same. So all the test environment could ask for production secrets to be decrypted as well. This is, they got so close to getting it right. In the previous example, they were using common runners for both test and production, whereas here, in this case, they did separate them. They were doing really, really well, but then they messed up the identity step of it. They messed up how the authentication happens between test and production, and they didn't separate what the runners identify as. The ultimate output of this was, so this was somewhat of a bank-related, relatively large bank running these automated runners to produce things like mobile apps and their internal apps as well. So the output of this was we were able to potentially backdoor banking apps that get pushed to production for customers, for you and I, but also to move money around using their internal apps. They were building internal apps for lots of different discrete problems internally. And ultimately, you could turn off point-of-sale systems. So you could move money, but you could also stop money from moving around completely, which has a very real-world impact. If you did that for real, you would definitely make the news. I think that wraps it up. So I guess my key takeaway is this stuff is really hard, and people keep screwing it up. We see this everywhere that we go. Everybody that's come on this CI/CD journey, they've started using runners, they've started using this sort of shared IT developer responsibility. It's very difficult to retrospectively go back and fix a lot of this, and so they don't. And the reality is a lot of it needs to be done correctly from day one, or you encounter these sorts of problems where developers don't know who built these runners, and the people building them don't really care about what they're being used for, and they don't differentiate between them. And the concept of where can a shared runner exist for test versus production, and that delineation has changed, whereas previously it used to be at a code level, now it's more at a build runtime level. I'm not going to run through this cheat sheet. This is here if you want it. I'm sure these slides will get shared around later. These are quite specific, but if you ever, I guess, in the aim of weaponizing this audience, if you ever start a job that uses any of these sorts of technologies, these are 6 quite critical steps that you could check for on day one to see if you have way too much access to things that are very, very easy. These are not bugs, these are not vulnerabilities, these are features of these products. And if there are any questions, I'll take them now. No? Alrighty. Thank you for listening to my talk.